For this question, you are given a derivative and you're given a function evaluation. So that means you're looking at an initial value problem and you're trying to find y. So what we're going to do is, and again, it might help to just write dy dx as f prime of x is equal to sine of 2x plus pi, and that is then in the same structure that we saw in class. So our first step is that we are going to integrate, and that will get us back to our original function. So if I integrate dy dx, that looks very awkward. So instead of writing that, I'm just going to write that I'm integrating f prime of x dx, and that will mean that I'm integrating sine of 2x plus pi dx. All right, now when you look at your integral here, you have parentheses, and anytime you have parentheses, you usually want to use u substitution. So in this case, our quantity in parentheses will start with as our u, so that will be 2x plus pi, and then our du will be equal to 2 dx. So using that as our substitution rule, let's make the substitution happen. So this sine of 2x plus pi, all of this 2x plus pi is going to get crossed out, and that is going to become u. So that will leave us with integrating sine u dx. Now, when we make the replacement for du, we see that we need to multiply in by a 2 to get the 2 dx, and that means that we need to divide by a 2 to balance things out. So this will give us 1/2 integral sine u, and then all of this 2x dx, that is becoming our du. So we are now ready to integrate because our integral is completely in terms of u. So remember, the sine and cosine you have to be careful about is DC negative. So integrate sine, you will get a negative. So we'll have negative, the 1/2 carries along, cosine u plus c. And then we'll make our substitution back. So our cosine u is equal to this 2x plus pi, and then plus c. All right, now working on the left-hand side, our integral and f prime, those guys are canceling out. So we get that this is our little f of x. Now, we do need to find our plus c value. So to find our plus c value, we are going to use the initial condition that was given as y of 0 is equal to 6. So here is what we are looking at. We're looking at that f of x is equal to negative 1/2 cosine of 2x plus pi plus c. If I plug in my 0, I'm going to have negative 1/2 cosine of 2 times 0 plus pi plus c. Now, of course, that is going to, in the parentheses here, collapse down to just pi. So I'm looking at cosine of pi. On the unit circle, we're over here, cosine of pi, and that will be a coordinate of negative 1, 0. So all of this cosine of pi, that is going to collapse down to negative 1. And then we still have the negative 1/2, and the plus c is equal to f of 0. So this, of course, gives us positive 1/2 plus c on the right-hand side. On the left-hand side, we're going to use that f of 0 is equal to 6, or y of 0 is equal to 6. So subtracting 1/2 from both sides, that will give us our c solved for. So, of course, you do need to get a common denominator here, multiply by 2 over 2. So you get 12 minus 1, so 11/2 as your c value. Now, once you get that as your c value, you are then going to combine them together. So you put it together, and you have your f of x as negative 1/2 cosine 2x plus pi plus 11 over 2. And that is your final answer.